All right, good morning, good afternoon, good evening, whenever you're watching this video. I'm going to quickly go over section 11 for the first part, how to figure out angle measurements inside and outside a circle. I apologize on how fast this video is going to be because I am actually trying to make it out to a track meet here that they want me to help out with, and then I'm going to be headed on to watch my oldest two daughters play a little soccer. So I'm quite in a rush. So just go ahead and copy this down on your paper there. A secant is any line that intersects a circle at 2 points. And so if I go ahead and draw a line here that crosses that circle, that's a secant. We call that a secant line. And this one will be considered a secant ray. Obviously, you know why line versus ray. We've talked about that since the beginning of the year. Now, there are two theorems that we're going to be looking at today, and I originally had laid out a real nice proof for you guys to look at and figure out and understand why the things are the way they are, but for some reason that video had an error with it, so again, I don't have much time. So here's what you need to know. The measure of an angle formed by two lines that intersect inside a circle is half the sum of its intercepted arcs, okay? And then the second one, if it intersects outside the circle, it's going to be half the difference of its intercepted arcs. Wow, really sloppy. Slow down. Okay, so difference. Anyways, sorry about how sloppy that is. But again, those are the two rules that we're going to be abiding by as we work through this worksheet together. So in looking at the very first one, number one, you see that you've got this angle here, and the intercepted arcs would be the arcs that the angles extend beyond. We have vertical angles that are congruent. So this is one intercepted arc, this is the other intercepted arc. And because the angle is inside the circle, it's going to be half the sum, so 88 plus 86. So x here is going to be 87 degrees. It's half the sum of the intercepted arcs when it's inside the circle. On the outside of the circle, like this one, it's going to be half the difference of the intercepted arcs. Now again, just like on the last one where the intercepted arc lies between the sides of the angle, this one's going to have the intercepted arcs, give me one second here. Sorry about that. Just wanted to make sure that I had everything on back there. So again, angles on the outside, it's going to be half the difference of the intercepted arcs. So the two arcs that are intercepted are these two that I've just traced there. So 90 minus 20 gives you the measure of x. So x is going to be half of 90 minus 20, which is 70, divided by 2, which is 35. So the measure of that angle is going to be a 35-degree angle. If we look at number 3, you see we've got the angle right here, which is x. The angle being on the outside is going to be half the difference of those two intercepted arcs. So the one arc is 150, and the other arc is 60. Okay, so half the difference of those two intercepted arcs. 150 minus 60 is 90. Half of 90, 45 degrees. Okay, so there's the first three problems there. Now, hopefully that was all straightforward for you. Made sense according to the theorems that we looked at. But for numbers, these that continue on from that, it takes that simple concept and expands on it just a little bit. It's not too difficult, so we just need to think about this. So if this arc right here is going to be x degrees, to figure out the other arc on the other side, it's going to be 360 minus that arc measure. And so, again, we start with the angle measure. 60 degrees is 1/2 the difference of the two arcs. The two arcs. Wow, that was bad. So we have 360 minus x, which is just this arc right here, and then we're going to subtract the other arc that it intercepts because the angle is on the outside of the circle. Okay? So as a result, my preference from here algebraically is to multiply by 2 to both sides to get rid of the fraction. And then from there, bring those two together, minus 2x. And then if you go ahead and subtract 360 from both sides, negative 240. And then from there, x will equal 120. Okay? Again, we're doing this like Blitzkrieg lightning war, right? Okay? Really quick. Looking at number 5, I'm going to get rid of number 5, the number right here, just so that it doesn't confuse you with anything. So angles on the outside, the two intercepted arcs, here, one's there. In order to figure out what the far one is going to be, I'm going to go ahead and take 360, this one right here, 360 minus 140, okay, this arc here, and then subtract x from that arc there to get what's left over. 360 minus 140 is 220, and so that's the measure of that arc right there. So to set up my equation, it's going to be 38 equals 1/2 the differences of these two arcs. So we have 220 minus x minus the other x, the other arc there. And again, you might want to pause your computer to go ahead and solve for x. I'm just going to do it real quick here because it's a time constraint. So 76 equals 220 minus 2x. And then from there, subtracting 220 to both sides, you get negative 144. And then dividing through by negative 2, you get x is equal to 72. Okay? So again, that's how you would go about solving for x within that problem. Number 6, you notice that in the previous two problems, we started with the angle measure first. I'm not going to change anything here. What is the measure of this angle? Well, the measure of that angle is not 6 degrees. That's the measure of this intercepted arc there. The measure of the angle is actually 90, so it's going to be 90 equals 1/2 the difference of the two intercepted arcs. This is one of the arcs. This is the other arc. So it's going to be x minus 6. So from there, again, if I double each side, and then I add 6 to both sides, 186, 6 would equal x. Okay? So that would be number 6. For number 7 and 8, the last two that we did in class today, for number 7, I would probably go ahead and solve for the measure of this arc right here by taking the sum of these two and subtracting it from 360. You're going to get 122 degrees. That's the measure of this arc. And then from there, if I go ahead and draw that angle that's formed on the outside of the circle with the two tangent lines, okay, this is going to be z degrees right here. And I know that this facing arc is 117 degrees. This arc over here can be the sum of these two, or subtracting 117 from 360. So you get 243 degrees. So z is going to be 1/2 the difference between 243 and 117. Okay? I'll let you guys go ahead and calculate that one out. Now, for y degrees, if I go ahead and draw another circle, y degrees will look something like this. I know this arc is 121. I know that the other two arcs added together would equal 239. And so y degrees will equal 1/2 239 minus 121. Okay? And so to find x, you could go ahead and subtract y and z from 180 because it is a triangle. Or you could go ahead and do the same thing we've done already. 1/2, you have the facing arc, which is 122. And the other two arcs added together would be 238. And again, you can go ahead and solve all three of those. If you did all three correctly, you should get a sum of this one plus this one plus this one should equal 180. Okay? All right, now, for number 7, again, the harder these problems get, the more busy they become with more lines. And so you have to really be able to focus in on what you're doing. And so the one thing I want you to notice here, center point, diameter, means that breaks my circle up into a half circle. So as a result, if this is 180 and this is 66, I know this is going to be 114, the difference of those two. If I look here, the diameter is perpendicular to the chord. That means that this chord is bisected, and it also means that the arc is bisected. So this arc measurement here is 66 degrees. Now, in order to figure out what this arc measure is, I'm going to go ahead and take 180 minus 66 and minus 60. So 60 and 66 makes 126. From 180 gives me 54 degrees. And so x, in this case being outside, is going to be half the difference, 114 minus 54. And so x, that would be 60 divided by 2 is 30 degrees. Okay? So I realize that was really fast, but what I want you to know is hopefully that gave you some information on how to solve problems numbers 9, 10, 11, and 12. I would like you to do those for tomorrow. Don't forget, you also have a quiz tomorrow over sections 11.1 to 11.3. This assignment will not be on the quiz. I apologize for how fast that had to be. Hopefully it made sense. I'll talk to you later. Good night.